Here we are at the definition for finding a derivative for an inverse function. So if you're trying to figure out what is the derivative of an inverse function, all it comes out to be is 1 over the derivative f prime with, instead of x though, we actually throw in our inverse function in, replace for x. So we have f inverse of x. So essentially, instead of f prime of x, you're again throwing that inverse function into that derivative. So let's actually kind of see this in action so it makes a little bit more sense with an actual example. When we're looking at example 1, we're asked use the warm-up to determine the derivative for this function. And again, we're trying to figure out what is that inverse, what is the derivative of the inverse. So f prime of x, because again we have to figure out according to the definition the derivative, that would come out to be 3x squared. Then if we're looking to try and figure out what is the derivative with respect to x of f inverse of x, so we're again taking the derivative of the inverse, just following our definition, that's 1 over 3 times, instead of x, again, we're going to throw in our inverse function anywhere that there was an x. So then we would end up with, from before, our inverse was x plus 1 raised to the 1/3 power. So anywhere that there is that x, we're going to throw in that x plus 1 raised to the 1/3 power. So we have x plus 1 raised to the 1/3 power. And that item is being squared. So this whole thing would be raised to the 2nd power. So just simplifying it up a little bit more, we end up with 1 over 3 times x plus 1 raised to, this is really a power to a power, ultimately you are multiplying those exponents, so that would be to the 2/3. So this then would become our derivative for the inverse of our function, f of x being x cubed minus 1. So again though, that is example 1 and the definition using the derivative for an inverse.